Today, we're making a twin-stick top-down shooter. For this project, I've chosen this asset pack called Robot Warfare by Matt Walkden. Looks like it was made with tactical RPGs like XCOM in mind, but it will work great for our project as well. I'll be developing the game in Catnip, the visual programming language for Ctjs. Start by importing and setting up the basic textures from the asset pack. The tile map and all the sprites use 16 by 16 pixels. The tile map has 16 columns and 16 rows. Don't forget to click Fill in the collision settings form after you've set up your tile set so that the collision matches the size of one tile. For the main character, I'll need a pair of separate textures, one for movement and one for idle pose. There was also an animation for shooting, but I forgot about it. Using the slice controls, I select only 2 frames in the first animation. For the second animation, I import the sprite for my main character again, create a second texture asset, and choose different frames. Duplicating the same source images like this is absolutely normal. The engine will deal with it and will only pack the necessary frames. I do the same thing with the first enemy, the spider, taking only its idle and walking animations. To make textures in the editor and in-game crisp, I enable pixel art mode in the project tab under render settings. It's a good idea to rename your textures so you don't lose track of which is which later on. After creating the textures, I build a room. I immediately change the grid size to match the tile count in the asset pack, which is 16 by 16 pixels, and set the viewport size to 320 by 240. Makes a 4:3 aspect ratio. If you want an aspect ratio of 16 by 9, use 320 by 180 pixels. First, I just slap a large set piece so I can get a feel for whatever the view size matches the asset pack. Then I spend some time drawing the level. The GIFs on the asset pack page help understand how tiles relate to each other and which tiles are used for floor, walls, etc. Place tiles on 3 layers. Base layer for the landscape and floors, one for walls, and another one for decorations that will be displayed above the player. To avoid confusion about which tile is which, I enable Colored Tiles mode under the eye icon. And so I made a small level with a park bombarded by aliens. Part of the park remains empty. Level design isn't the focus of this video, so it's fine. I also set up viewport restrictions in the room settings so the camera doesn't go outside the level boundaries. Next, let's talk about creating templates, and the most important one is for the main character. But to control them, I need actions. Here, I use a preset template for movement in 2 axes. Simplest code for movement is assigning horizontal and vertical speeds to actions values, the multiplier. Put the multiplier in a property called max speed, assigning it in the copies creation event. This will allow us to easily adjust the character speed later. Correctly configured actions give values from -1 to 1, depending on which direction the copy moves relative to the axes. Together with the multiplier, this sets the speed of copy movement in pixels per second. With such simple code, the character will move diagonally faster than just left to right and up down. You can fix this by limiting the speed using the mathematical operator minimum, where one argument is the current speed and the other is max speed. So we make sure that the speed is not higher than the maximum. Finally, I put a block, move this copy, stopping at the collision group. The collision group can be called anything, and for non-passable objects, I usually call it solid. I rate the same name in the room for the tiles layer with walls. Next, I center all the textures of the main character and mobs so that it is easier to place them, and so they rotate around their center, not like doors around a corner. Then I place the main character in the level. In the room settings, specify that the camera should follow the copies of the main hero. Time for testing. And here's the first problem. The character doesn't squeeze through the passageway. To fix this, you need to make the collision mask smaller so that it better matches the texture contours. Don't forget to copy the resulting mask to the rest of the textures of the main character. Done. Now he'll squeeze through. I'll make the hero's speed 1.5 times higher though. In In the end of frame event, I add some simple code so that the character looks in the direction it moves. To do this, I check if the horizontal speed is negative, and if so, I change the size to -1,1 to reflect the texture horizontally. Don't forget to reset the size back to 1,1 for positive horizontal speeds. Time for testing. They wiggle. Splendid. Add a texture and create a template for the cursor. To make your own cursor, you can simply change its position to that of the pointer at the end of each frame and hide the standard cursor in Project's render settings. For now, I just drop the cursor's copy in the room. Have the cursor appear on top of other objects, assign it a very high depth value. The cursor is interesting, but quite strange because its frames go clockwise first and then counterclockwise. You can't make one formula for all the 4 frames. So, I add 4 conditions, assign a variable mouse direction to them, and assign the variable with a value equal to the direction from the current hero's position to the pointer. I also store the reference to the hero in a variable, and retrieve it through the template's copy list. It's an array, so a numbered set of values, but since we only have one main character, they will always be at position 0. Here it's also important to add a condition. Is the hero's reference even valid? They might already be dead and removed from the room, and trying to access values of a deleted copy will result in an error. Here you can observe me methodically laying out the blocks, although I could have done one condition first, and then duplicated it 3 times with new values. It also turned out that I accidentally put the block not for changing the coordinates of the copy first, but for changing the coordinates of the camera. The essence of the algorithm for switching frames is simple. If the angle from the hero to the pointer falls within a certain range, we change the texture frame using the goTo frame and stop block. Next, I add an animation to the player's character. If their speed is greater than 0, then we assign a positive animation speed. If not, we set it to 0. Don't forget to tick Play Animation on Start in Appearance settings for this template. The value of animation speed should be less than 1 and means how much you need to advance the animation forward in 1 frame of game. They walk. Splendid. Next, we'll create the player's projectiles and shooting mechanic. To do so, we'll need to use our own timer instead of built-in events. This will allow shots to happen immediately when you press a button, but have a cooldown. It's not complicated. Timer, I create the shoot time variable, which will decrease by the time value from utilities category on each frame. This block returns the time passed from the previous frame. When the timer is less than or equal to 0 and we have pressed the required key, you can create a copy of the projectile and reset the timer to a new value. That equals the desired pause. In the bullet template, in its creation event, I set the movement speed, and also a timer by which the copy will be automatically deleted. This ensures that copies that have flown outside the screen do not fly forever and use up RAM. The copy will also be destroyed when it collides with objects of the collision group solid. Later, I go back to the hero code. I create a bullet copy at the hero's coordinates, and save a reference to the created projectile in the projectile variable. Through this reference, using the withCopy block, I change the direction of movement of the projectile to the angle between the location of this projectile and the position of the crosshair. Also here, initially there was a mistake. Timer should still be updated on each frame. To make the hero shoot automatically while pressing a mouse button, I also needed to replace the action is pressed block with the action is down block. Testing. It shoots. Good. I also decided to add a simple effect of bullet impact using animation from the asset pack. This template should play its animation once and disappear. For this, I enable the animation in the appearance panel of this template, but disable its looping playback. This allows you to use the event animation completed, where I delete the copy. In the template of the bullet itself, I add the block in the destruction event and create a copy of the created animation at the current coordinates of the bullet. Now the bullets have a nice effect on impact. Now it's time to code the enemies, at last. Plan is as follows. The enemy will have two variables for its AI. While the hero has not crossed a certain distance, an enemy won't chase them. The distance to the player will be checked in a timer. This check will become more complex later, so it makes sense to perform this not every frame but at an interval. But for now, I get a reference to the hero from the template copy list, check that it's valid, and compare the distance of the enemy to the hero with what I set in the variable aggro distance. If the hero fell into this radius, the variable aggroed is set to true, which allows the chase logic to be executed in the frame start event. If the hero did not come into the radius, timer started again. In the frame start event, if the hero exists and the enemy has been aggroed, the spider moves towards the hero and changes its movement speed and texture to the walking animation, and moves, stopping at objects, the collision group solid. If the condition was not met, the spider changes its texture to the normal idle texture and resets the movement speed. A block called Move This Copy, stopping at the collision group, will allow the spider to slide along the copies and avoid simple obstacles. I scatter several spiders on the level and adjust the animation speed. Testing. Spiders chase the hero as soon as they get close to a certain distance. Now we can program projectile interactions with the spiders. I've set the bullet's collision group to hero projectiles. It is not necessary, as you can use the event collision with a template, but using the collision event with a collision group will significantly ease your life if you want to add multiple weapons with different ammo types. I've added a collision event for the spider with the hero projectiles collision group. This event has a special variable other, which is a reference to a colliding object. In our case, it's the bullet. We delete this bullet with the with copy block and reduce our own HP, and if the HP reaches or falls below 0, we also delete the spider itself. Don't forget to assign the HP value in the spider's creation event. Finally, we can fight back those horrible creatures. I've added a block to my spider so that it will definitely aggro when hit by bullets. Next, I decide to make the fights more visually appealing by adding blood effects. I set up the blood texture as usual and create a particle tandem. The particle tandem editor opens where you can add multiple emitters, each of which will create its own particle effect. One emitter should be enough here. To better understand how the emitter will look in-game, I plug in the spider's texture for preview. Next, I change the transparency of the particles so that they remain mostly visible, adjust the size of the emitter to make the blood flow more densely, set the direction of the particles from 0 to 360 degrees so that the blood flies in all directions. Then I adjust the number of particles created at a time, the interval between two releases, and the lifetime of the emitter to make it release only once. After several other tweaks, I'm happy with the result, and I'm ready to put it in the game. In the enemy spider template, I add the fire and emitter at location block, specifying the created tandem and the spider's coordinates. The blood flows. Splendid. Time to enhance the logic of our spiders so that they aggro only when there is a clean line of sight between the hero and the opponent. To do this, we need the trace line block. It takes an object formatted in a certain way that describes the line and a collision group, as well as a flag indicating whether we need to find all the colliding copies or if one is enough. The form of the first argument can be seen in the documentation of the module. We need to create an object with fields x1, y1, x2, and y2, specify the coordinates of 2 points for this line. For this, we will need the create object block, and we will store this object in the trace line variable. We specify our current coordinates in one point and the hero's coordinates in the other. Traceline command returns either a copy or a tile with which it has collided with, or false if there was no collision, so we can put the result as is in the if block, the operator not, because we don't need to know what exactly was collided. If there was no collision, the line of sight is clean and you can attack. Testing. Spiders now only attack when there are no obstacles between us. Blended. Now let's go back to the main character. Right now they are immortal, and that needs to be fixed. For the hero's health values, I will use global variables. They are accessible everywhere, and it is easier to use them when creating a graphical interface. In the hero's creation event, I set initial values. In the spider's algorithm, I created an event for the collision with the main character and added a new variable, attack delay, that will act as a timer, an interval between attacks. It will work similarly to shooting, but the condition for resetting the value will no longer be the action, but the event itself of the enemy collision with the hero. If during the collision the timer is less than or equal to 0, we reset the timer back to the desired duration in seconds, subtract health from the hero, and create a blood effect at the hero's location. For the death of the hero, I create a template similar to the bullet impact template. This is a template with an animation that plays once. When the animation ends, I start a short timer, after which the current room is restarted. I augment the frame start event of the hero so that they disappear and create a copy of the death animation at their coordinates when their health reaches or falls below 0. Testing. A lot of blood, that's suspicious. Blood was spawned every time the spider collided with the hero, but it should take into account the attack interval. Oh no, nothing happens at all now. Ah, forgot to set the initial value for this attack timer. Now the spiders can eat the hero. Hooray! The last edit in the spider's algorithm, I improved the condition for movement so that the spider does not move if it is already quite close to the hero. It is important that the distance check is after the validity check. The order is important, and if the distance check tries to read the location of the killed hero before checking the reference to them, an error will occur. We can now create the interface. For this, we need a room with the same view size as the main room, that is 320 by 240 in my case. We also need to mark this room as a UI layer in the settings, otherwise it will not be placed correctly on the screen. For health, I have cut out a heart icon previously with a sprite. This texture will be repeated and therefore cannot be cut out directly from a large texture like we did with animated sprites. For the health counter template, I choose the basic class sprite counter. I also removed the standard event with a movement block because this element will not move. In the room for the interface, I add 2 copies of counters. One of them will display health, and the other will be darkened and placed under the first to display maximum health. Through the UI tools, I select each copy and write the names of the global variables Hero HP and Hero Max HP into the field called Sprite Count. To get the room on the screen, it needs to be added to the main scene through the creation event of the room. Here, we need the block Append a Room. Testing. The main character is torn apart. Blended. But you can tear them even further and improve gameplay by adding a new type of enemy. There will be huge hornets that are weaker but significantly faster and able to ignore obstacles. Once you see several similar templates, it means it is a good time to use behaviors. Behaviors allow you to modularize gameplay logic by using the very same events. However, one template can use one or more behaviors. Plus, with behaviors, you can add new fields to the template editors for easier configuration. First, I add most of the spider's properties into custom behavior fields: HP, aggro radius, movement speed, and attack interval. These will be available as both properties and input fields in templates where we add this behavior. I also add an isFlying field to mark which enemies ignore obstacles and which don't. It will be used in the frame start event and will determine whether the movement uses collision checks or not. Next, I create events and transfer all blocks from our spider into the behavior. Only the frame end event remains inside the spider's template, which for some reason I initially deleted. I also forgot to transfer the timer code for the aggro check. The code for animating the spider will differ from the animation of the hornet, so there's no point in dragging it into the behavior. I add the new behavior to the spider and configure it according to its past values. The previously created behavior fields appear in the Properties panel under the Appearance tab. I also add the behavior to the hornet template, and there I give these enemies only 1 HP, faster speed, and mark them as flying. The shooter is almost done. I just want to change the shooting mechanics a bit so that the hero's gun shoots in bursts and has an option to reload. To do this, I add two new global variables called current ammo and max ammo, and assign them starting values in the hero's template. In project settings, I add an action to reload, which is bound to the R key. When it's pressed, I start a 1.5 second timer in the hero's template, after which the number of rounds is reset to the maximum. This will be the manual reload. I also extend the event for pressing the reload key so that the timer only starts if it hasn't already been started. You can check this by making sure the timer value isn't a positive number. I modify the hero's code so that when the shooting timer expires, it first checks if there are any rounds in the clip. If not, it starts the reload timer, if it hasn't been started yet. I also shorten the interval between shots to balance out the introduction of the reload mechanic and decrease current ammo by 1 on each shot. Testing. It works, except shooting could be a bit faster. All that's left is to add an interface. Here, everything is the same as with the heart counter. I import a carefully cut texture, add a template with a base class sprite counter, add it to the existing room interface, and through the graphical interface tools, bind its values to current ammo and max ammo. I also changed the layout of the interface a bit so that the empty slots are semi-transparent. And there you have it. You can now mow down aliens. If you want to continue this project, here are some ideas for it. Adding sounds and music. Make several levels and transitions between them. Add a few types of projectiles and limited ammunition. Have the enemy's aggression spread to nearby enemies when one is aggroed. Try the trace a circle block. Make a main menu and simple save system that loads the last level. If you like this video, or if it has helped you with your own Ctjs projects, you should consider subscribing, commenting, and liking the video. Please the YouTube algorithm overlords.